All right. Hello, everyone. I'm Bernd, and today is day 21 of Advent of Code. So today's problem takes us back to monkeys. Our input will be a list of monkeys, and each of them will shout a number. So some monkeys directly will shout a number given by this integer, and some numbers will wait until the friends shout a number and then shout, for example, the sum or the product or so on. And for the first part, we just want to know what the monkey with the name root shouts. So how do we solve this? Of course, we need to read the file and split it into lines. And then we want to convert these lines into operations. So for that, we just split it by the colon. And then we want to have to convert these operation strings into actual operations. So that we just define if we have a plus symbol, that means we take two values and add them. If we have a minus symbol, similar, and so on. We define division here because there can be some problems with division. In particular, like in standard division will not produce an integer, so that's kind of annoying. So we make sure that first the b is not 0, that's not great for division, and then we also make sure that a is divisible by b as integers, and then we just return the integer division. So they will throw some errors if it's passed bad values, so just to catch some errors early. Then main function will be the set value. So we want to set the value the monkey shouts in this monkey values dictionary, and we obviously need the operations to be able to do that. So how do you do that? So if the monkey is already in the dictionary, we don't need to do anything, we just return. Otherwise, I will get the operation string, and then this operation string could be either an integer or this like operation where it says two monkey names and a plus in the middle. So first we try converting into the integer as integer. If that raises a value error, it's an operation and we need to do something else. So that we know we can split it by the this character, and then we get the name of the first value, the operation name, and the value of the name of the second monkey. Then we get the operation, we set the value for each of the monkeys we need. And then again, we'll have that the monkey value of the current monkey will be the operation applied to the value of the first monkey and the second monkey, and we know that these values exist in the dictionary because you set them just before. And then in order to solve it, we just get the operations from the lines. We initialize the monkey value dictionary as an empty dictionary, and then we set the value of the root, which iteratively will set all the values of required monkeys, and then the solution will just be the value that the root shouts. We can run a little test for that. And with a bit of luck, yes, that works as well. Nice. So yeah, that's it. Part 2 was a bit different. So there turns out there's a value, a monkey with the name human. And it turns out that's not a monkey, but that's actually us. And depending on what value we'll shout, the root will shout a particular value. Or like other monkeys might shout values depending on the value we shout. And then we want that the root, so the root has two monkeys it waits to for shouting, and we want that those two monkeys shout exactly the same thing. And if they shout the same thing, we win. So we want to find the value we're supposed to shout, so that the two monkeys watched by root shout the same value. So in this case, we again can take a few things from part 1. What we need to adapt is the set value function. So first, we just want to kind of inspect the problem. So again, we go through all the monkeys. If we already set the value for this monkey, we're done. If the monkey has my name, has our name, is like the human, then we'll just set this value to x. So this time this dictionary will be a dictionary from a string to either an integer or a string, which in the string will be the term that the monkey will shout depending on our value. Okay, and then we get the operation string. We try to set it if it's an integer, and otherwise we again split the operation into the monkey names and the operation name. We set the value of the children, and then we check for both the other monkeys. If it's an integer, then we know we can just calculate the current monkey's value as the operation of these two as before. And otherwise, one of them will be like a term, like a string, like x or so. And then we just want to set the current monkey's value to a term that describes its value. So the operation string will just be the first monkey's value, the operation name, and the second monkey's value. And both or either of these or both of these could be strings themselves. And we set that, and we can just run solve with that and see what happens. So it turns out then the root has the following equation, which is quite long. But importantly, so x will only appear once in this whole equation. So if you look through it, x is only appearing here and nowhere else. So that makes the problem much easier to solve. So x could appear a lot of times. A lot of monkeys could be waiting for what I'm shouting and then adjust the value correspondingly. But in this case, it's much nicer because we only appear once. And so what we can do is, if we know the value, so we have the goal value of the two monkeys watched by the root, we know that these are supposed to be equal. So we can go backwards. If you know what this value is supposed to be, then we're done, right? Because we can just take the goal value and add this 898. Similarly, if we know what this term is supposed to have, the value this term is supposed to have, we're also done because we can just take the goal value, divide by 24, and then add 889. And similar going further, again, if you know what this value is supposed to be, we are done as well because we can just subtract this value, divide by this value, and add this value, and so on. So we'll do that in code. So for that, we'll define the go backward function. We'll take as an input a monkey name and this goal value. So for the root, for checking whether M2 and M1 have the same value, we just decide to subtract their values, and then we know they have the same value if the root has value 0, just to make things a bit easier. So yeah, so with this formulation of the root operation, we want that the value of the root is 0, and we could define this go backward function. So in order to go backward, we need to know how to invert some statements. So for example, if we have x plus right equals solution, then we know we can reformulate that to x equals solution minus right, and so on. If we have x minus right equals solution, we know we can calculate x, the goal value for x, as the solution plus r. So just define this if x is on the left of the expression and if x is on the right expression. And again, always we have like this map from, so if we have plus, we have like this map from the right value and the solution to what x should take, in this case x minus r. And similarly for the left, so for example, if we have left divided by x equals the solution, we want to have the value of x should take is then left divided by the solution. So again, if we have a map that has this division operator to that then maps a value for left and a value for the solution to the value that x should be taking. And again, we have this division which checks if b equals 0 or we can do integer division. And if both of them are not true, so we can do integer division, we just do the integer division. Okay, so with that we can define the go backward function, so with a monkey and the goal value. And then we check if the monkey is me. Then we know we're done, we know the value we should be shouting, and we can return that. Otherwise, again, we get the operation string, we split into the first monkey, the operation, and the second monkey. And then we get their values, and then we check if the value for the first monkey is a string. That means we have something like a term for the first value minus an integer m2 equals to and we want this to be equal to some goal value we define. Then we can just get this left goal functioner or get left goal functioner by using this dictionary and the operation name. And then we know the new goal, the value these brackets should take, is this get left goal, where the right value is m2 value and the solution is the goal value. And then we just iteratively go backwards in order to evaluate, go back to x, we go backwards and the node will be m1, the new goal we just calculated, and yes. Similarly, if the m2 value is a string, so then we have something like, for example, m1 value, which is an integer divided by this term equals to goal value. So we want to know the value this should take. So then we have this get right goal value dictionary that will help us get this get right goal function. And then the new goal will be this get right goal, where the left value is equal to m1 and the solution is equal to the goal value. And again, then we go backwards. In this term, the node to evaluate is m2. And the goal is again the new goal. Okay, with that, yes, we can run the code or run a test. And we see again, we get like this root equation out in the first part, and then if we go back, we get the correct solution. So that is nice. And yeah, that's it for day 21. I enjoyed today's puzzle. I hope you did as well. Best of luck for the future and see you around.